Hello, I'm Samana Shrestha and I'm going to give a short lecture on projectile motion. Projectile motion. So projectile is anything, any object that moves under the action of gravity alone. Say I throw this in the space and it falls down under the action of gravity alone. So this is a projectile. And here I'm going to show what would be the trajectory of a projectile motion, what would be the instantaneous velocity or the maximum height attained, the time taken, the time of flight of the projectile and the horizontal range of the projectile. Let's see. I have a projectile in here. I throw a projectile with an initial velocity u0 at an angle theta with the horizontal. So this initial velocity being a vector quantity, it can be resolved into two components, one along x-axis, say ux, which is u0 cosine theta, and the other is along y-axis, say uy, which is u0 sine theta. So this horizontal component u0 cos theta is responsible for the horizontal displacement of this projectile, whereas the vertical component u0 sine theta keeps changing. So in this picture, this is the maximum height, say h max is the maximum height attained by the projectile. This is the horizontal range, the maximum displacement attained by this projectile, whereas the total time t is the time of flight, the time spent by the projectile in the air itself. So I'm going to find out, I'm going to derive the equations for the horizontal range, the maximum, the maximum height attained, the time of flight, instantaneous velocity, and say arbitrary position. Also, I'm going to show at what angle should the projectile be projected so that it attains the maximum displacement. As this projectile moves at each and every point, the velocity keeps changing. This would be the direction of velocity, whereas the magnitude of this velocity is determined by this horizontal component, vertical component at that particular instant, whereas the horizontal component remains constant throughout the motion and the vertical component keeps changing. So as the particle goes up, the velocity decreases and becomes 0 here, and then it keeps on increasing. First, let me find the time of flight. So as the velocity goes from here to here, so I'm worried about only the vertical component of the velocity, whereas as I already said, the horizontal velocity remains constant. So the vertical velocity here becomes 0 because at the maximum height, the velocity is 0. So using equation of motion, I can write, so I use the equation of motion v equals to u minus zt. I take negative acceleration because the particle is moving in upward direction. So these are the y components, because so vy here is 0. So uy is u0 sine theta equals to gt. This gives u0 sine theta equals to gt. So the time taken is u0 sine theta by z. But this time is the time taken by the projectile to go from here to the maximum height, whereas the total time of flight would be twice that time. So the total time of flight is 2 times u0 sine theta divided by z. Now let's talk about the maximum height attained. So again, I use the equation of motion. Say I use v square equals to u square minus twice zh. Again, the negative sign is just a sign convention only, indicating that the particle is moving against gravity. And the velocity here being 0, this is the velocity, initial velocity along the vertical direction. So h max here is uy, which is u0 sine theta, u0 square sine square theta by twice z. This is the maximum height attained. Similarly, horizontal range is the horizontal distance traveled by the projectile throughout its motion, throughout the time of flight. So this is the first one I derived, this is the second one, and for the third one, the horizontal is simply being displacement. It is the product of the velocity times the time of flight. And the velocity for its horizontal motion is just u0 cos theta. Just u0 cos theta is responsible for the horizontal displacement. So displacement times time is twice u0 sine theta by z, and 2 sine theta cosine theta gives sine 2 theta, and you have u0 square here divided by z. So this is the horizontal range. Now from here, for this horizontal range to be maximum, Sine twice theta should be maximum, and the maximum value of sine twice theta is 1, which is sine 90. So twice theta gives 90 degree. That means theta is 45 degree. So we can say that if we project a projectile at an angle of 45 degree, it attains the maximum horizontal displacement, or say horizontal range. And using these two equations, I can even find the relation between H max and R. Let's divide equation 2 by 3. So dividing equation 2 by 3, I get H max divided by R equals to U naught square sine square theta by twice Z U naught square sine 2 theta Z. These get cancelled, these get cancelled. So I have sine, I have tan theta, and 2 comes from it, here 4. So H equals to R tan theta by 4. This is the relation between H max and the horizontal range. Oh, the board is very small. Now, let's see the arbitrary let's first find the trajectory of this projectile. We know the horizontal displacement here is x. Distance is speed into time, where x equals to u naught cos theta times time. T is the instantaneous time at any instant, and y equals to, this is the vertical displacement. As I said, for the vertical displacement, u naught sine theta is responsible. So from here I can say uyt minus half gt square. This is also from equation of motion. So y equals to uy is u naught sine theta times t minus half gt square. So solving for sine theta, let's solve for sine theta. Let's solve for t in here. So we get u naught sine theta. So you have x divided by u naught cos theta minus half g t square, and we get tan theta times x minus half gt square, and this is comparable to y equals to ax plus bx square. Or we can say, let's substitute the value of t square in here. So substituting the value of t square, we get divide by u naught square cos square theta x square. So this equation is comparable to y equals to ax plus bx square, where this equation is the equation of parabola. So we can say this projectile follows the parabolic path. So the trajectory here is the parabolic.